Hello, everyone. Right now, we'll do a quick lesson on the activity series and oxides. Not too long. I believe we may have already reviewed it in class, but let's go over it now. So all this is posted in our Google Classroom and accompanying homework as well. There's a worksheet on it, and there's reference to a page in your textbook. If you have both, great. Otherwise, it is actually sufficient to just access the Google Classroom and refer to the worksheet posted there, and I'll get to that at the end. Fortunately, this one isn't too long. We'll continue to post more. Okay, let's get started. Actually, before we do, this is also posted in our Google Classroom. It's a full course, lesson by lesson, topic by topic plan. I'm working on adjusting a few things as well myself. Now, what we've done, fortunately, our first unit was quite lengthy. We've covered a lot. Look at all the topics we covered in our first unit, Unit 1. All the way, almost a full page. So Unit 2, I know we were able to cover law of conservation of mass and balancing equations. You also did types of reactions, had a good amount of practice with that. Also addressed some neutralization as well. In class, we would have done a titration lab. I'm going to come up with find a simulation that can help you with that. But in the meantime, we're going to continue. Also, a lab that would have been great to do. We'll do some kind of simulation online. Is incomplete and complete combustion. That was going to be more of a self-created discover kind of lesson where you would have figured out what that was on your own. I'll post something as best as I can, something similar to that for our purposes right now through online learning. So that will come. For now, though, I do want to get you guys started. Fortunately, this is a pretty short unit, so I'm going to do a couple of topics which won't even take too long. And the next thing we'll do is we'll do incomplete and complete combustion, although I think you may have actually gone over the theory. Perhaps you did in class. We'll finish off our unit then with solubility rules. So this is quite new. We'll do some practice there. And continuing with solubility curves and supersaturated solutions. And last topic is ionic equations and total ionic equations and spectator ions. But for now, what I've highlighted here, metal activity series and non-metal oxide, metal oxides are what we're going to cover today, or right now. Okay, so getting to our lesson here, I'll just put it in presentation mode. Okay, so I may have some cheesy PowerPoint sound effects, but feel free to ignore those. So, two main topics today. I would normally have gotten into a bit of neutralization as well. So you'll see that there is a couple of slides that may not fit into this lesson, but there was normally going to be a bit of background behind that, but we'll get to that later. Right, so the activity series and oxides. Now that includes metal and non-metal oxides. Now feel free to pause this video whenever you'd like, to take some notes, to rewind a bit, and then play again. That's the idea behind these pre-recorded lessons. Okay, moving on. So there is, to the right here, your metal activity series with hydrogen just over here. Of course, not a metal, but we throw that in there as well. And you won't need to memorize this. So on any future test, quiz, exam, however that may look like now, don't know exactly, but for any future assessment or evaluation, you will not need to memorize this. You will have access to this. I'll give it to you. Somehow I'll embed it into whatever question, however format, how that will look like in the future, don't know. But for now, this is your metal activity series. Metals at the very top are more reactive than the ones at the very bottom. And the idea is that the metals at the top will be able to displace a metal that is at the bottom. So if you look at this reaction, iron and copper 2 sulfate. Now, in the past, you would have had to have performed an experiment to figure out if a reaction would have occurred. Now, what you're able to do is you're able to predict using the metal activity series if this reaction will take place. So we see that iron, we locate iron on this list, and iron is right here. If you follow my cursor, copper is just below. Now, because copper is below, iron is able to displace it, so it's able to bump it out. So that means this single displacement reaction will happen, and iron will bump out copper. And this is the reaction then. Copper will now precipitate, if I had states written here, this would be a solid, so solid copper would form, and iron 3 sulfate would be created. Moving on. Same for lithium and hydrogen. So lithium at the very top here, almost at the very top, is above hydrogen. So that is lithium is able to kick out hydrogen, and it will now create, now this is a bit unique here, metals and metals and water. And we've actually seen this reaction in class. Lithium and water will create lithium hydroxide. So hydrogen will be displaced. We'll get lithium hydroxide and hydrogen. So the part that you would copy down, the part that you would make sure to take note of, is the part that is in blue, right? Everything in blue in our lessons you would write down normally. Hoping you are still doing that as you continue learning at home. So make notes before we start, and then you can watch these videos, or in conjunction with make notes while you are watching these videos. That would work as well. So essentially, what I've said is listed here, is stated here. The activity series ranks the relative reactivity of all of these metals, and used to predict if metals will, if these reactions will proceed in a single displacement form. Okay, so a bit of practice. So which of these will react? Here we already saw that iron and copper 2 sulfate do react, but we've thrown that in there. So nickel and sodium chloride. So let's see. Nickel, find nickel, it's right here. Now sodium and sodium chloride, sodium is above there. So will nickel, so right there. So will nickel displace a metal that is above it? No, it will not. Because nickel is not above sodium, no reaction will happen there. And we'll answer the first one. Yes, iron is above copper, but we were looking at nickel. So no reaction will happen. Nickel is not above sodium. Sodium is above nickel, so there will be no reaction. Next, lithium. Is lithium above zinc? Yes, lithium is right here. Zinc is right there. Because lithium is above zinc, lithium will displace zinc. So a reaction will occur. Now, when you are completing reactions like these, I'll complete that reaction. So they will switch. You do have to remember that their valence charges, their oxidation states, or numbers, I should just call them valence charges, will need to balance, right? So we know that zinc has a positive 2 charge, carbonate has a minus 2 charge, so you only need one of each as a reactant here. Now, when you displace zinc with lithium, that charge has to be balanced. So the -2 copper with now a positive lithium would require 2 lithiums, because lithium has a +1 charge. Because copper has a -2 charge, you need 2 lithiums, so we see Li2CO3. Now we have gone over balancing equations and making sure that they're electrically balanced as well, so you hopefully have some experience. You do have some experience actually with doing just this, both in our first unit, and we reviewed it again at the beginning of this one. Okay, now aluminum. Aluminum and copper. Aluminum, if we find aluminum's right here, and copper is below it. So the question is, will aluminum displace copper? Well, because it's above it, right, it will displace copper. And a reaction does take place. Now, again, in this reaction has to be electrically balanced. So we see copper as a precipitate and aluminum chloride. Now, aluminum has a +3 charge. If you look at the periodic table, aluminum is on the third, well, I'm going to say third column, but we really know it's on the 13th column, which it's just skipping over the transition metals and has a +3 charge. So if you have a periodic table in front of you, this isn't something you have to memorize. It's just in the periodic table, aluminum has a +3 charge. With a +3 charge, and with chlorine here being a halogen having a -1 charge, you need 3 of these -1 charges to balance out the positive aluminum. +3 aluminum. Okay, so that is essentially it for the activity series. We're going to move on. We would have practiced a bit right now, consolidated what we learned in practicing, right? Now before we move on to metal oxides and non-metal oxides, I just want to go over some basic definitions. Right, we have reviewed acids and bases when we did nomenclature in our first unit, but just to go over it once more, if you recall, and we're gonna further define this in more detail. But for now, acids are anything that will release hydrogen ions. Now that is a correct definition. It isn't a complete one. We'll get to the more complete one later this unit. So bases are then when hydroxide is released. Okay, so moving on. Metal oxides. So just as the name implies, non-metal oxides. Non-metals in their oxide form will behave a certain way. I like to remember, or it helps me remember, that non-metal oxides dissolve in water to form acids by remembering that. Now, I'm not just picking on Coca-Cola here. It's any carbonated beverage. So any carbonated beverage we know typically to be acidic, right? We have to take care of our teeth, take care of our enamel. This is enamel corroded by what? So in this picture here is a picture of someone's, looks like their top incisors. You can see some enamel wearing away because of acid. Now this isn't just this soda beverage's fault. It's anything else. Orange juice, lemonade, citrus fruits, even coffee can do that. So you've got to take care of your enamel. And I remember that these carbonated beverages have CO2 inside them. Now, carbon is a nonmetal. Its oxide form is oxide. So carbon dioxide, name of the oxide form of carbon, when that is dissolved in water, and it's quite easily dissolved in water, when that's dissolved in water, it creates carbonic acid. Similarly, if you have sulfur, that'll create, well, I think I actually have to correct this here. CO2 dissolved in water to give carbonic acid. Okay, here we are. And so sulfur, no, just a different example thrown in. So this can be, right, this could be looked at as sulfite if there was an AQ here, but sulfur trioxide will then give sulfuric acid. An example of a nonmetal sulfur, its oxide version, creating an acid as well, in this case sulfuric acid. Right, so carbon, nonmetal, oxide version gives you an acid. Sulfur, a nonmetal, if this were dissolved in water, it would give you an acid as well, in this case sulfuric acid. So in a nutshell, before we move on, nonmetal oxides, when dissolved in water, form acids. Okay. Now the opposite happens with metal oxides. So if you remember that CO2 creates in water an acid or carbonic acid, in that case, then the opposite for metal oxides takes place. A metal oxide, when dissolved in water, forms bases. Good example is calcium oxide. When calcium oxide dissolves in water, it's actually missing a step here. I will, at another point, connect a sketch pad so I can write and go along as I go along with these presentations. But I'm going to close that, and to this presentation, I'm going to add something. Now, it's not going to be well formatted, but bear with me. I should change the. Well, this will work for now. All right, calcium oxide plus H2O. It should be subscripted, but for now, we'll leave it like that. We'll create calcium hydroxide. This 2 should be subscripted. I'll do it in a bit. Plus. Okay, let's see. Where is a subscript? Oh, this isn't worded. It doesn't have a shortcut button here. See if it's. Here we are. Oh, it is subscript. Interesting. Oh, it's all subscripted. That's why. Okay, that too should be a subscript. I'll fix for formatting later. So that is what happens. That's the first step. So calcium oxide in water creates calcium hydroxide. Now calcium hydroxide, I'm going to rewrite that here. Calcium hydroxide, subscript 2, in the presence of water, so I'm going to write AQ, will ionize or will dissociate into its ions. which is what you see right here. Calcium ions and hydroxide ions. I'll just quickly rewrite that here. So calcium 2 plus ions and 2 hydroxide negative AQ ions. Right, so this is a two-step reaction here, but essentially, going back to our presentation mode, a metal oxide, calcium oxide, in water will create a base. Calcium hydroxide, which will dissolve or dissociate, not dissolve, will dissociate into calcium and hydroxide ions, making it into a base. Now, at this point, I would show a video on the reactivity of different metals. Now, we actually fortunately did this in class, so you got to see lithium and sodium react with water. Great experiment, great demonstration. Shows you the different reactivities, referring of course to the activity series in our case right now. We would normally have talked about indicators and probably showing you a demonstration of a titration apparatus. We'll do that later as a simulation, but now don't worry so much about that, except that there are different kinds of indicators. We generally use only a few of these in high school, but we have phenolphthalein here is the typical one we use. We also use bromothymol blue. You would see some litmus paper perhaps used as well. So we'll use this as a simulation that I'll find for you at another time. But these pH, these indicators test for a visual representation of something that is either an acid or a base. For phenolphthalein, if it's pink, it's a base. If it's acidic, it's just clear, right? So if I said calcium oxide inside water, what color would it change? Knowing that it's a base with phenolphthalein in it, it would turn into a pink color, as an example. That's it for this lesson. Here is where you can go to practice. There is a worksheet posted online called Single Replacement Reactions. I didn't give it the title. I would have called it Single Displacement Reactions, but that's where you can go for some practice online. If you have your textbook, you can go to page 204. You can do questions 2 to 9. Until next time.